Hi guys, Mr. Johnny here, and in this video I want to make hopefully a short explanation how I made this converter in this meter that I put together. I consume only 10 microamps in this off position and start up just fine without adding any external switch whatsoever. And I did that by implementing a feedback line. And that feedback line is thanks to the feature of this meter, which is auto power off. And how it's implemented. Okay, so roughly the auto power off feature in this meter is implemented in this fashion. The main switch is a double pole double throw switch, which in its off position connects 9 volt from a battery. Let's presume it's a battery here. So it connects a 9 volt battery to this capacitor, which has a resistor across it, and this provides a time constant. Then there is an op-amp LM358 which compares the voltage on this capacitor with some sort of a reference. I just drew two resistors connected to 9 volts line. I don't know what kind of reference they're using, but it's definitely in this kind of way. It's a comparator, which in turn, through a resistor, I didn't draw one for simplicity, turns on this transistor, which supplies the stuff being the circuitry in a meter with current, and it also supplies 9 volts to this feedback line, which goes to the converter. So in the off position, this cap is charged. It sits at 9 volts. Let's presume it's powered from battery. It's no converter, 9 volt battery. So the moment you push it on, you supply 9 volts to the comparator, which sees that voltage here is higher than here because this cap was just a second ago connected to 9 volts, and this 10 meg resistor will take quite a while in order for it to discharge to the threshold here. So it pulls its output low, thus pulls the current out of the base of this transistor and supplies the current to the stuff. So that's how it works. And when this capacitor discharges, the voltage here is now higher than here, output goes high and turns this transistor off. And then what you need to re-trigger it is to push the button again to depress it in the off, so it will be in off position. That will charge the cap again, and then push it again, and that will provide you with another 10 or 15 minutes. I don't remember. So I used this collector here as a node of choice because it is at 9 volts when the scene is on, and it is at 0 volts. It is in high impedance state. I would say there's some sort of pull down by the stuff, so this is not 9 volts in the off position. Now, sometimes it starts just fine because this cap in off position will be charged to about this voltage minus diode drop, because the current flows like that to this net and charges this capacitor. And the moment you press it, you effectively supply this battery voltage minus diode drop to the op-amp, which might start, but it might not start. It starts up just fine on 2.5 volts here, but I tested it at 1.5 volts. The boost converter itself works just fine on 1.5 volts. That doesn't bother it, but this op-amp does not. And you have 1.5 volts here, minus 0.5 here, 1 volt here, not enough. This thing is off. So that's why I added this kickstart feature, which I didn't install yet because the battery is reasonably charged. So all it does is it kickstarts the oscillator. So you make sure the button is in off position, so effectively output of the converter connected to this cap. Then you press it for a short period of time, like a tap, like that. it supplies the current to this base, oscillation goes, charges this capacitor as well as this capacitor, and the moment you push this button, the energy from this capacitor goes to the op-amp, which pulls the base of this transistor low for a short period of time, but it's enough to provide a burst of current here, which will keep this thing oscillating, and the thing will latch just fine until this cap discharges and it auto powers off. Yikes. So I hope that gave you a quick idea how did I implement that feature, and to be honest with you, I don't even know where those 10 microamps I mentioned in a previous video go. They might very well go into circuitry in the multimeter rather than here. I actually need to take this node connected to ground, disconnect the output from the meter and measure it again, because I'm not sure where that current goes. It might very well be leakage through parts, but 10 microamps is perfectly fine. So that's that, guys. If you have any questions, leave them in the comments below. Thanks for watching. See ya.